9.5 of these trucks full of water are unnecessarily transported every day. How can we make this more sustainable? Hi, I'm Nick.
I'm Stefan.
And I'm Kevin.
We are participating in the PTTP Friesland Campina challenge. During this challenge, we're going to help Friesland Campina making the residual streams from cheese more sustainable and together work on our future. This is where it all starts. The milk produced by cows like these will be transported to Friesland Campina's factory. One of the products made in this factory is cheese. While producing cheese, 90% of the milk will become a residual stream. The residual stream, which we call whey, still has a lot of valuable components, including lactose sugars, calcium and whey proteins. To make use of the whey, it gets transported to another factory to produce products like protein powders, ricotta cheese and whey butter. In the case of Friesland Campina, this translates to about 10 trucks a day. 95% of whey is water. If this is reduced to 57%, we will save 8 trucks a day, which is an equivalent of 700 tons of CO2 per year. The reduction of water content is a widely known and used process, but only up to 28%. In our case study, we developed a system design to go up to 43%.
So, how are we doing this, you might ask? We designed a 3-step process to concentrate the whey in the most efficient manner possible, without damaging the sensitive proteins. To start off, we used a conventional filtration process, consisting of ultrafiltration to filter off the protein fraction and reverse osmosis to concentrate the whey up to 25% dry matter. The third step is the more challenging step, for which we propose the use of a rotating film evaporator. Due to the high concentration of lactose sugars, crystallization will appear during this step. This makes for complexities with the use of conventional evaporator systems, since the crystallization will result in clogging of the pipes. The rotating film evaporator is different and propels on and scrapes off a thin film on the surface of the heat exchanger, which allows for better handling of the concentrate. This makes for a complex system and is therefore a bit more expensive. The last step of the system is to mix the separated proteins from the ultrafiltration step back in with the concentrated whey stream. Due to this system, the sensitive proteins didn't get any harsh heat treatment and are therefore still fully functional. In conclusion, by using this process, we will concentrate up to 43% dry matter and reduce the amount of water by about 7 times. This is the equivalent of 8 trucks a day with a reduction of 450 tons in CO2 emissions per year.
This all sounds really promising. But what about the cost of this process?
We broke down the cost by equipment, their electricity and steam uses, and the savings we provide by choosing for this system. Ultrafiltration and reverse osmosis are both low in cost, maintenance and electrical usage. The rotating film evaporator, on the other hand, is relatively expensive medium in maintenance and use a medium amount of steam. When summing up the estimated equipment price, we will end up with a total cost between 4 and 5 million euros. The total yearly cost of electricity and steam comes down to almost 200,000 euros a year. By reducing the number of trucks needed, we save 1.2 million euros a year, which gives us a return of investment time of 4.5 years.
With our process, we can concentrate up to more than 40% dry matter. Therefore, we can save about 8 trucks a day, reducing CO2 emissions by 450 tons a year. Further handling of the concentrate needs to be investigated. We believe that we can provide a sustainable process optimization. Now it's up to you to decide.